This video is a continuation of the time value of money concepts video. In this video, we're going to look at amortization schedules, which is a time value of money concept, as well as the calculation of a monthly loan payment. Let's use an example here. Let's say that we have a $20,000 student loan. Well, at this time, the interest rates on student loans are at about 6%. And so therefore, a student loan payment is monthly, so you would have 12 payments or 12 periods per year. The monthly interest rate would be equal to the 6% divided by the 12 periods per year. So the monthly interest rate is equal to a 0.5% in this case. Let's say that this loan would stretch for 20 years, so therefore the total number of payments would be equal to the 12 periods per year multiplied by 10 years. So the total number of periods as well as the total number of payments would be equal to 120. So therefore the calculation of the payment is a time value of money calculation. Up here in Excel, I'm going to click on the Insert Function button, and in this case you can type in simply PMT and hit Enter 2 times, and then you get the function arguments boxes. Okay, so the interest rate is going to be equal to the 0.05% or the periodic rate. The total number of periods or total number of payments, notice it's saying calculate the payments, and P is the total number of payments. Total number of payments is equal to 120. And the outstanding loan balance, which is equal to the present value, is going to be equal to $20,000. I'm going to click OK. Notice that my payment shows up as a negative amount, which if you make a payment, that's money out of your pocket. Nonetheless, I would prefer to look at this in absolute terms, so I'm going to change that simply just by inserting a negative in front of my or behind my equal sign in my formula. So for a $20,000 student loan that you have to repay over a 10-year period of time, your monthly payment would be $222 per month. So with that in mind, it simply is an indication of the need for caution and restraint when taking out those student loans. A $220 monthly payment can be a considerable burden for an individual that's just finishing up with school. That over a long period of time 10 years is a long time to make that payment, and it's a lot of money. So the next part of the video here is to apportion each one of these payments between how much of each payment goes towards interest and how much goes towards the payment of principal. I've broken my table down into 3 columns. Column 1 is simply the month. Column 2 is the loan balance. Column 3, the monthly payment. 4 is how much of each payment goes towards interest. 5 is how much of each payment goes towards paying off the loan balance. And finally 6 is how much or what the loan balance is immediately after making the loan payment. And notice here that I've also described how each one is calculated. But let's look at the example. In this case, the loan balance is equal to, indeed, the loan balance. That's pretty simple. The monthly payment is going to be equal to the monthly payment. And now I'm going to use some absolute referencing here. I'm going to copy this formula later. I want dollar signs to be in front of the C and the 7 for the Excel function of referencing. The amount of each payment that is that is applied to interest is a function of the balance of the loan and the periodic or the monthly interest rate. So therefore, how much of this loan payment goes towards interest is equal to the balance of the loan multiplied by the 0.05% or the monthly interest rate. Once again, I'm going to use the F4 key to get dollar signs in front of my C and my F, and I'm going to hit enter. So in this case, of the first $222 payment, $100 goes towards interest. What doesn't go towards interest goes towards paying off the balance of the loan. So therefore, how much goes towards interest, or paying off the balance of the loan, is the amount of the payment minus how much goes towards interest. The remainder goes towards paying off the loan balance. And then the loan balance is equal to the beginning loan balance minus the amount that we just paid off equals the ending loan balance. Now, the beginning loan balance is going to be equal to the ending loan balance in the previous line. Now, everything else remains the same. Once again, interest equals the amount of the loan balance multiplied by the 0.05 using my referencing, $99. So now a little bit less because we've paid down the loan balance a little bit. Now on our next payment, a little bit less goes towards interest because the loan balance is smaller. And just a little bit more goes towards paying off the balance of the loan. How much is that? Equals the monthly payment minus how much went towards interest identifies how much we paid off. And therefore, the balance afterwards is equal to the beginning balance minus how much we paid off, gives us the ending balance. Once you have that in place, you can just go ahead and copy this down to 120 time periods, and voila, exactly after your very last payment of $222.04, the balance of the loan is exactly zero. Another interesting concept is, notice how in the early part of the loans, a big chunk of the payment went towards interest. In the very end part of the loan, of the very last payment of $222, only $1 went towards interest. Almost all of it went towards paying off the loan balance because the balance of the loan was relatively small, and so there's very little interest that needed to be paid. That's how an amortization schedule works. And one of the very important concepts in all of finance is identifying the fact that every single consumer loan has an amortization schedule that is attached to it, so that every time you make a monthly payment, part of that payment is a portion towards interest, and part of the payment is a portion towards paying off the loan balance. Once you've created a table like this, then you can come in and kind of play with it a little bit. Let's change our facts a little bit. Let's say rather than a $20,000 student loan, we have a $100,000 home loan. Okay? Right now, home loans are going for about 0.035%. And that would be on a 30-year loan. On a 30-year, $100,000, 3.5% loan, the monthly payment would only be $450. Now, one of the other things with home payments is you have to pay off part of your payment goes towards principal and interest, of course, but in addition to that, home loans are a little bit special in that many people have to pay part of their property taxes because it's a big expense with home ownership, and part of their homeowner's insurance is another big part of their homeowner or their ownership of a home. They have to pay 1/12 of that to their bank, and their bank sets that money aside for them and pays the bill on their behalf. So the $450 only applies towards the loan payment, but does not include the taxes and insurance apportionment and escrow. Okay, but let's look at this. On a 30-year loan of $450, notice that almost $300 goes towards interest and only $155 or a little bit more goes towards paying off the loan balance. Let's say that what happens if rather than a 30-year loan we change this to a 15-year loan? Would you expect the loan or the payment to double? You might expect that, but that's not what happens, because as you start paying more and more money towards paying off the loan balance, less goes towards the payment of interest. So rather than doubling from $450 to $900, our loan amount only goes up to a little over $700. Once again, because we're paying more towards the payment of paying off the loan balance earlier, and less goes towards the payment of interest. In addition to that, we left our interest rate at 3.5%, but as the number of years on a loan goes down, so does the interest rate. So you'd be able to go from, if we went from 30 years to 15 years, well, right now, instead of 3.5%, we'd probably have 3%. So if we enter in 3%, wow, if we have, about 3%. And 15 years, we went from $450 to only $550. Boy, at this day and age, it would be hard to turn down a 15-year loan in comparison to a 30-year loan. That concludes the overview of the amortization schedule and the calculation of a loan payment.